Hi guys, it's Kachi once again. Welcome to my YouTube channel. If you are new here, please kindly subscribe. Today we'll be discussing on advanced object concepts. So I already did on the basic of object in my last video, so we'll be taking it a notch further today. So we'll be discussing on object oriented programming, which is I think a better way of organizing code in JavaScript and in programming as a whole. So it's basically an advanced object. So I'll be defining some of our concepts here. We'll be discussing on the this keyword in object-oriented programming. We'll be discussing on privacy. We'll be discussing on getters and setters. We'll be discussing on factory functions in objects. I know you've asked here what's factory functions in there. We'll discuss on factory functions actually. We'll be discussing on destructuring in object-oriented programming. So it's packed. It's fully packed. So just keep in touch. Let's go straight to it. So let's start with defining our object first. So let's define an object, a school object. School equals to an object that has a name, which is King's College, and number of, if I can spell that well, what am I writing? Number of students, which is 200, and we have location, which is, I guess, Yaba. I want to guess, I'm not sure. And we'll define a method. Now a method is a function within an object. So when we find ourselves, I'm writing a method now. when we find ourselves defining a function, this is a function now within an object, that is now a method, which returns this statement: the name of my school is this dot name, if I can write that well, this dot name, and we are located at this dot location. Now the first thing I told you we're discussing is the this keyword. So this keyword is this keyword. So this refers to this object here. So when we say this dot name, it is relative in the sense that it's subscribed to the object within which it's called. So because this keyword is called in this provide info function that is within this school object, so it subscribes to the name of the school. So if you call this outside this curly braces, it refers to the global instance of the Node.js this, that's the whole global this object. So but because it's how will I put it now, it's restricted, or it's limited to this curly braces here, this school object. So then this name now is now referring to, is now pointing to this school name here. This is actually kind of complicated anyway. this keyword is kind of complicated, but what you should know is that whenever this keyword is used, it subscribes to the object within which it's called. So it points to this here, the school object. So if we console.log provide school.provide info, calling it, and we go to node index, you see the name of my school is King's College and we are located at Yaba. So it points to the name and the location because it's called within the object. Hope that's clear. So we can also call other things here. We can also call the name of the school dot name, and it will give you King's College. So that's that for that. So now the next thing we'll be discussing is privacy in object oriented programming. So privacy is a concept that helps us to know properties within an object which is not to be which is supposed to be unchanged, left unchanged. It's not supposed to be changed. They are immutable. So let's say you want to define a property and you want to let your people that are reading the code, either subsequent programmers or just people that are reading the codes, to know that this particular field is not supposed to be touched. It's not supposed to be changed. It's supposed to be left that way. Then you have to use the concept of privacy. Now, the fact is just a way of denoting that this particular figure, this particular property should be left unchanged. Now, the fact that it is denoted as being left unchanged does not mean that it cannot be changed. It can actually be changed, but we are pointing to people to let people that will be reading our codes to let them know that this particular property should be left unchanged. So how do we do that? How do we do that in object-oriented programming? We do that by defining our keys with an underscore. So let's say we have a school budget. So we do it this way. So this underscore will point to people. This underscore here will point to people that this budget is not supposed to be changed. If you get that, it's supposed to be left the way it is. So it's like a way of storing value that you want to be left the way it is, basically. So that does it for that. Now, but before we go to getters and setters, now let me show you this. The fact that, like I said earlier on, the fact that it's denoted with the underscore mark does not mean that it cannot be changed. And you can see, I can come here and say school dot underscore school budget equals to 5,000. So if I print out to the console school dot underscore school budget, it will show you 5,000. So it can be changed, but like I said earlier on, we're just informing our readers that these figures should be left the way it is. So the next thing we'll be discussing in object-oriented programming is getters. Getters is simply a method of returning the internal properties of an object. So we're trying to get some properties here. So we define it with a method called getters. So it's a bit different from regular functions. So or regular methods. So how do you define that? So let's assume we want to get our school budget. So we say get school budget. Get school budget, which is a method, like as you can see, it's like somewhat similar to this provide info that we have here. Get school budget. It's almost similar. Just the difference here is just this get keyword here. So now we want to get the school budget, which is this particular thing here. So but we want to make some checks. First, we want to check that actually school budget actually exists. That is number one thing we want to check. And then number two thing we want to check is that the figure, the value of school budget is actually a number. So we want to check that school budget exists and the value is actually a number. So we don't want to print out a sentence, for instance. We want to check that it's actually a figure. It's not something else. So we'll do that by saying if this dot school budget and type of this dot underscore school budget is strictly equals to number, return the budget of our school is template literal. This dot, what am I writing? This dot school budget. Else we return what? Sorry, cannot retrieve school budget. So let me format this document. Okay, it's okay. So we are checking this. We are checking to see if this school budget, if this exists, and the type of this dot school budget is number. Then we print this out. The budget, if we print out the budget of our school is, this figure. Else we'll print out sorry, cannot retrieve school budget. Now I explained in my previous video on functions, conditional rendering. I explained the different kinds of conditional rendering, the ampersand, what this means. So if you haven't watched that video, please check it. It's there in my playlist, JavaScript playlist. So you'll see there, you see I explained almost all the different form of conditional rendering. So you see it there. So let's just check this. Let's just try it out. Let's just see if it's gonna work. So console.log school budget. So it actually works. Why? Because the the school budget actually exists and it's a number. But if we change this now to a string, now a string is denoted by apostrophes. Sorry, let's say apostrophes, quotation mark rather. So it could be single quotation mark, it could be double quotation mark, it could be template literals. So sorry, it could be template literals, right? So let's check this now. We have changed this to a string. It's not a string. So it gives you sorry, cannot retrieve school budget. So that shows that our getters is actually working. So the next thing that is in line with getters is setters. So we can actually set our school budget. Yeah. So it's also a function that takes in a parameter, which is the budget, the new budget we want to change it to. So we are setting our school budget by giving it a new value. So we're taking in that new value as a parameter called budget. So first and foremost, we want to check if budget is strictly equals to a number. We don't want to set our school budget to this should be type of. If type of budget is strictly equals to a number, because we don't want to set our school budget to a string, a function. We want it to be a number, a figure. So if type of budget is strictly equals to a number, and the budget is actually the budget is, we want to check if it's greater or equals to 0. The reason we are checking that again is because we don't want someone to put our budget to be minus 50. Doesn't make sense. So it has to be equal, either 0 or more than 0. If that two condition is met, I'm not spelling my school budget well, so I'll change it to the correct one. If that two condition is met, we would reset our this.school budget to the new value here, budget. Else we'll console.log what am I writing? We'll console.log a string that says, sorry, please kindly input a number. Please kindly. Sorry, budget. Sorry, please, budget has to be a number. It's better. Has to be a number. To be a number. So we are checking two things. The type of, it has to be a number and it has to be greater than 0. Here, so right here, if this condition is not met, we'll now console the log. Sorry, please, budget has to be a number. Let us leave it like that. It doesn't really matter. Let us leave it like that. So let's come here now, and we can now say school budget equals to 100, which is the number. So let me change this to a figure. Let me change this back to a figure. So yeah, this school budget is 3,000. So it's 3,000 here. So but now we are calling our setters function here, school.schoolBudget, and we are changing the value to 100. So now this our function will check for two things. One, that this particular figure we are giving it is a number, and number two, it's that this particular figure is actually greater than 0. So if we console the log school budget, you will see that our budget has been changed to 100, and it prints this. The budget of our school is 100. So we set it here, and we call it using the getters. So we set the school budget using the setters, and we call it using the getters. So our getters now get the school budget, which is down the updated figure 100. So if I change this to a string 100, watch what will happen. It gives us, sorry, please, budget has to be a number. Why am I using sorry and please? Why am I using those two words? Let me just remove one. Sorry. Okay, sorry, budget has to be a number. Sorry, but I say it has to be a number. So it retains our previous, our previous school budget, which is 3,000. So it retains this. It doesn't reassign it to 100. But so that does it. That does it for setters. Setters helps you to reassign the properties of our school, and getters helps you to get the values of those properties. So this can work with. I can use this same function for the name, for reassigning the name, reassigning this number of students. You can reassigning the location. So we can actually use it for those other properties. So the next thing I'll be discussing here is factory functions. Now, let me explain this with an illustration to help us understand better. So imagine you are working with the Ministry of Education in Lagos State, and you are to keep track of all newly opened schools in Lagos State. So that's your job description. So you can imagine that manually keeping track of this information will be very, very tedious, because every day we're having new schools coming up, springing forth every day. So what you want to do is to have a predefined model that, okay, all the schools in Lagos State have this particular, they have what will I say, a related a kind of related properties. So all the schools have a name, all the schools have a location, all the schools have a number of students, all the schools have a number of teachers, all the schools have related properties. So you want to define a model that has those related property, and so that when a new school comes up, you just input the figure based on their uniqueness. Okay, so if the number of students in this particular school A is 100, you just put it there 100. So the next school that comes in, the number of students is 50, you just put in the 50. You don't have to start redefining the school every time a new school comes up. So you just follow the properties. It's way much more easier and simpler than having to redefine, the school instance every time. So we do that using factory functions in JavaScript. So So this for, let me just write this out. It will help you understand better. So we will just say cons school model. This is the overall model of the school, equals to a function that takes in two parameters, the name and the location. Yeah. And the location, yeah, name and location. And it will return an object here that the name equals to the name and the location equals to the location. So now this name here is the parameter. Let me explain this better. So this name here is an object. This is an object. Remember I told you, wherever you see an object, wherever you see the curly braces, refers to an object rather. So this name here is the key, and it points to this name here. So this name here, this particular name here you're seeing here, is undefined for now. It's just a parameter, it's a placeholder for the name we would be imputing to our school when we start creating the school. So this is just the model we are defining now. So the location is the same thing. So this location is pointing to this particular location, which is undefined, just like a placeholder. Be here for now. It represents the location we'll be giving of the school that we'll be defining later on. If you get that. So we can also have a welcome message, which is going to be a function that says welcome message that says that console.log welcome on board this dot name. Now we are seeing that this keyword again, so it points to what? The name. It points to the name here. So this name, it points to this name here, which is here to be defined. So once we define the name later on when we are defining our schools, it will point to that particular school name. So it will become welcome on board, the name of the school here. So now this is name, location. We can actually use ES6 so we can actually use the ES6 model by saying name equals, since name is equal to name and location equals to location, we can actually use the school name and the school location here, as you can see. So you can do like this, name, location. It's much more easier, but for the sake of understanding better, we'll leave it this way. So now here, we now define our school here. Const school1 equals to school model. We are calling in this instance. We are calling in this instance here. So school model, passing in the name of this particular school that we are creating, which is King's College. And the location, which is Yaba. So we can have multiple schools. We can have school 2. School 2. This will be Methodist Girls College. College, which I know this is in, this is at Yaba, but King's College I'm not sure. Things that Obalende also, I don't really know. The next one, we can have a school. We can have as many schools as possible. Like I said, we can have school 3, which is which is going to be my school, my secondary school, which is Heritage College, which is at Itam, yeah, Uyo. So that's that. So we can console.log to get the values here. School 1, not school model, school 1, not school model, school 1 dot name. So this will be school 2 dot name, and this will be school 3 dot name. So you can start seeing where we are going to. So it gives you the school 1.name has King's College, school 2.name has Methodist Girls College, and the school 3 has Heritage College. So this is easier. You are defining the school just by calling the school model and passing in the name of the school and the location. Now, what you must know is that they have to be in the same order. You cannot put Yaba first before King's College. It has to be in the same order you define this, which is name and location. So that's that. King's College and Yaba, Methodist Girls College, Yaba, Heritage College, Itam Uyo, and that's just it. So we can also call the name school 3 dot welcome message. We can call this function. This is a function now. We can call it, and let me just console.log this. Let me just comment this out. Welcome on board Heritage College. So this welcome on board takes in this dot name, and this dot name points to this name here that we are defining. Name equals to the name, and here in our school 3 we define the name as what? Heritage College. That's why it's pointing to this dot name, Heritage College. If you get that logic, so that's how that's how it works in factory function. So as you can see, it's much more easier. It's much more easier defining as many schools as possible than having to every time doing it this way. School is equals to name, college, name of, and all that. So it's just stressful. So you can just define a model, a factory function, and just calling the name and passing the figure, the values. It's simpler, it's easier, it's better. So if you don't understand anything here, you just drop a message in the comment section and I will respond to it. So let me comment this out. Let me comment all of this out. The last thing we'll be discussing here before calling it a wrap is object destructuring in JavaScript. So in JavaScript object detection. So I think I did object destruction earlier on, but but let's do it again. So for those that that were not there. So object destructuring is basically a way of ES6 a model of getting the values, the properties of our object. So now let's say we want to get the name of this school. Yeah, how do you think we'll do it? We'll do it by simply printing out console.log school.name, and it will give us King's College here. So if you want the number of students, we'll just do number of students. So that will be 200. So you can see, for us to get the name, we have to say school.name, school.number of students, school.location, school.provide info, school. Sure. So it's stressful having to put the school each time. So what if we just define a variable and pass in the value and just call the name by the newly defined variable? Rather than just say cons name of school is equal to school dot name. That's much easier, right? So when we come here, we just console.log name of school, and we'll get King's College. It's much more easier. For me, I think it's much more easier than having to write school. It's stressful. So we can also do with the next thing. Do the same thing with the next value, which is number of students. You can say number of students equals to school dot number of students, and if we print out number of students, it gives you 200. From there, we can now use the figure to do whatever we want to do. So that's just basically it for I know it's been a lot. We have done a lot of things here. If you have any issue, just send a question on the comment section. So if you struggle with what we just did here, I refer you to my videos on functions, my videos on objects and my videos on conditional rendering, because we made it of conditional rendering here. I made it of objects, so it's it will help you give you a better understanding before coming to this. This is like the intermediate level. So that's just it. So keep in touch, stay in touch with my YouTube channel. If you are new, please kindly subscribe to my channel, and I'll be dropping more videos, more complex videos, which you have to you'll be scratching your brain. So just keep in touch and we'll just learn together. Thank you and bye.